So here's some factoring methods, and there's about 7 of these, so we'll go through them one at a time. The first one is a common factor in each term, so I've got some examples here. This is kind of like the antidistributive property. What you do is you take a look at this, and we have first of all, how many terms do we have? Well, I've got 2 terms. Do I have a common factor in each term? Well, there's a 3 in both terms, and there's also an x, so I can factor out a 3 and 1x. So I'll take out a 3x. And then what's left in the first term is just 1x. And what's left in the second term is 2, because 3 goes into 6 twice, and we have a minus sign. And then you could always just use the distributive property to check it. That's going to be 3x squared, and that's going to be negative 6x. That checks out. If we look at example number 2, we've got a trinomial, 3 terms, and each term there is a factor of, it looks like, 7. So that's what I'm going to factor out, so I'll take out the 7. And what's left in the first term, I divide each term by 7. 7 goes into 7 once. So there's just 1 in the first term. Minus 7 goes into 21 3 times. And an x is left. And then 7 goes into 35 5 times. So that's plus 5. And then there's a y left. Okay. And you could always multiply this out and check it. And you'd have 7 times 1 is 7, minus 21x, plus 35y. So it's really easy to check. Okay, the next one, example number 3, we have a trinomial. And if I look at each term, I've got 3 terms. There's a 5 in each term, and there's also an x in each term, so I can take out a 5x. What's left in the first term? If I divide the 5 out, I have 1, and if I take x out, I get x squared, so I just have x squared left. Second term, I can take the 5 out, and I have 1x left, so I just have x. And here I can factor out an x as well as a 5, and I just have left negative 2. And you can always check this again by multiplying it out using the distributive property. 5x cubed plus 5x squared minus 10x. And you always try this first. Always check for a common factor in each term, because if you can find a common factor, that's going to simplify your work. Okay, this next one has got 3 terms, because remember, terms are separated by addition or subtraction signs, so these are both plus. So this has got 2 terms. Each term has got 2 factors, but the second factor in each term is what we call a more complex factor, or a binomial factor. So if we look at these 3 terms, is there a common factor? And there's a common binomial factor. And I ran out of room over here, so I'll write this in red. And my common factor is x plus y. So I'll factor out the x plus y. And if I divide that out, what's left in the first term? Just a 5. Second term, x, and the third term, y. So I factored out that x plus y, and what was left I just divided. 5x plus y divided by x plus y is just 5. X plus y divided by x plus y is just x. And y, x plus y divided by x plus y is just y. So divide this out. You can always check it with the distributive property. 5 times this is that. X times this is that. And y times this is that. So that's a little bit more interesting problem there. Okay, and the second method is the difference of perfect squares. And you could kind of work this out. If we multiply a plus b times a minus b, a plus b times a minus b, and we use the FOIL method, first times first is a squared. Inside, ba or ab, minus out, or outside, negative ba or negative ab, they're the same. ba and ab are the same. And positive b times negative b is negative b squared. So if we multiply this out, the inside and outside terms zero out. In other words, plus ab minus ab is 0, so we have a squared minus b squared. So in reality, we know that if we have a squared minus b squared, it factors to be the product. It factors to be the product of the sum and difference of the square roots. In other words, what's the square root of a squared is a. What's the square root of b squared? That's b. And this is going to factor to be just the sum and the difference of these square roots. A plus b times a minus b. And that's pretty much how you deal with these. So here's example number 1. And these are my perfect squares. I wrote over here the perfect squares. There's 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 times 4 is 16, 5 times 5 is 25, 36, 40, that's just 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 20 squared is 400, so that's one that pops up once in a while because it's easy. So here's some examples of the difference of perfect squares. First of all, it's going to be a binomial, so you look for a binomial. If you see 2 perfect squares, you're pretty much in business as long as it's a difference. It's always the difference, not the sum, but the difference of perfect squares. So what's the square root of x squared? Well, that's x. And what's the square root of 81? 9. So I can identify the square roots. So I know that if I've got the difference of perfect squares, it's going to be the product of the sum and difference of these little numbers. So I just put the x there, and the 9 there, the x there, and the 9 there. And if you multiply that out, you get x squared. 9x minus 9x is 0, and then positive 9 times negative 9 is negative 81. So it's very simple. The difference of perfect squares. We identify this. The square root of 4x squared is 2x, so that's a perfect square. The square root of 49y squared is 7y. And I have the difference of perfect squares, so I know it's just going to be the product of the sum and the difference of these little numbers. 2x plus 7y, 2x minus 7y. And those are, again, the square roots. Okay, the square root of 16x squared is 4x. The square root of 9y squared is 3y. So I got the difference of perfect squares again. So again, it's going to factor to be the product of the sum and difference of these little numbers, which are the square roots. There you go. And over here, this is also a perfect square. The square root of x squared is x. The square root of y to the 4th is y squared. And if you multiply x squared y squared times x squared y squared, you get x. I'm sorry, if you multiply x y squared times x y squared, you get x squared y to the 4th. And the square root of 25 is 5. And the square root of z to the 6th is z to the 3rd. In other words, if you multiply z to the 3rd times z to the 3rd, remember you add the exponents, and you get z to the 6th. So again, this is the difference of perfect squares. If you want to take the square root, you just divide the exponent by 2. All right? And now we know we've got the difference of perfect squares, so it's just going to be the sum of the difference of these little numbers up on top, which are the square roots. X, y squared, 5z cubed, and the same thing over here except the difference. X, y squared, 5z cubed. So those are your first methods. Common factor, which we always try common factor first because you can simplify that. That's going to make your work easier. And then the difference of perfect squares. Okay, hope those all make sense.